Hello and welcome to the MSc Computer Science Individual Project Personal Data Receipt presentation by Tom Falpel. The presentation will introduce the concept of the personal data receipt. At this point, I would like to specifically thank Dr. Geeta Chaudhry Mustafawi, Dr. Navin Ramachandran, and Mikhail Nati from Digital Catapult for their help and support. Over the course of this presentation, the reader will be informed about the goals and aims of the project, the context of the project, the solution including the design and implementation, and a critical evaluation of the project. The problem at hand is the introduction of the General Data Protection Regulation in 2016, which will be enforced in May 2018. Organizations that deal with personal data need to ensure that they comply with this new legislation. For the client of this industry project, bookmyscan.co.uk, a new service has been proposed, the Personal Data Receipt, which will be a lightweight, portable, cost-efficient and secure way of complying with the new GDPR. The project-specific deliverables, also called goals, are going to be prototyping a simple software application that can be integrated into the current business model of the client, enabling compliance with the GDPR, develop a JSON model for a personal data receipt. The prototyped software application should generate a personal data receipt and send it to the recipient. Finally, the hash storage on the IOTA tangle should be investigated. In addition to the project deliverables, 8 personal aims were established. Firstly, to learn the Python programming language. Secondly, to learn the Django web framework. Thirdly, apply the learned technology in building a lightweight application. Fourth, gain insight into blockchain technology. Fifth, investigate and learn about the IOTA distributed ledger, also called the Tangle. Sixth, develop an understanding of the GDPR. Seventh, experience the process of an industry project. And 8th, pass the Medical Research Council Certificates of Research Data and Confidentiality e-learning course and Good Research Practice course. Now, with the goals and aims established, let's take a closer look at the context of this project. First of all, what exactly is the General Data Protection Regulation? The GDPR comes in to replace the existing Data Protection Act from 1998. Its main goal is to ensure the correct handling of personal data and includes 8 personal data rights for each individual. Those are the right to be informed, the right of access, the right to rectification, the right to erasure, the right to restrict processing, the right to data portability, the right to object, and rights related to automated decision-making and profiling. So why is it this important for companies and organizations to comply? Well, in case they don't, they can be penalized with monetary fines up to 20 million euros or 4% of their annual global turnover, which is easily enough to render a lot of companies and organizations bankrupt. The GDPR covers all data that is classified as personal data and applies to organizations even outside of the EU if they're dealing with EU citizen data. Now we'll move on to the explanation of what a personal data receipt is, or in short, PDR. A PDR is similar to normal shopping receipts for any kind of transaction. In this case, it is a transaction of personal data that has been handed to a given organization, which is going to store the data in the database. The PDR will include details about what data was received, for what purpose the data is stored, with whom the data will be shared, for how long the data is stored, and where the data will be stored, whether in the EU or outside of the EU. It states the GDPR rights of an individual and provides a first point of contact, allowing the individual to manage his or her data. The PDR is based on the research done by Tatiana Stagliari and Mikhail Nati from Digital Catapult. The intended solution will be written in Python and a standalone application that can be attached to the client's existing main web server. In the following diagram, the data flow of the complete architecture can be seen. The clinician first selects the time frame and scan type, which are then sent to the hospitals and imaging centers. Those send back the available time slots they have. These are going to be shown on the Book My Scan website, and the clinician can then choose one and enter all the patient details. The details are then going to be stored in the database of Book My Scan. Once that is done, a booking confirmation is going to be sent to the clinician, to the hospitals and imaging centers, and to the patient. The Book My Scan backend then uses the JSON model that was created to send a JSON file to the personal data receipt backend containing only Boolean fields. Those will indicate whether the type of personal data has been captured and is stored at bookmyscan.co.uk. The JSON file is then used to create the PDR, which is sent via SendGrid to the patient. An additional step would be to hash the PDR and store the hash value on the IOTA tangle. Now we can see a live demonstration of the PDR prototype, which has been deployed locally. The current view shows the data input stage, which is almost the same like the bookmyscan.co.uk data input. Once all data has been inputted and we press the submit button, a confirmation view is shown where the hash value of the JSON file is shown and the direct link to the PDR can be found. In the PDR view, we can see to whom the PDR is addressed, the information about what type of data has been received and is stored, the purpose for collecting the data, and of course the GDPR rights. If we now check the mailbox of the recipient, we can see that an email has been received and it shows the exact same personal data receipt. To summarize, the system has been split into a few individual components. One of the main component is the JSON model, the personal data receipt generator that uses an HTML template to generate the PDR, emailing, which sends an email via SendGrid API, hashing, where the JSON or the PDR is going to be hashed using SHA 256. And finally the IOTA component, which will store the hash value on the IOTA distributed ledger. Of course, over the course of the project, a few challenges had to be faced. One of them was that the codebase received from bookmyscan.co.uk was stripped of vital information and hence was therefore unable to be used. The second part and more challenging aspect is the IOTA programming. At the moment, no stable library is available, which means that a lot of the functionalities can only be implemented through trial and error. In addition, the IOTA tangle is a very abstract and challenging technology to understand, therefore requiring a lot more time and testing. Looking at the previously mentioned goals and aims, it can now be clearly stated that all goals and aims have been achieved so far. Given more time, extended goals can be reached. With an additional 6 months, the project could be structured in a much more sophisticated way. Using a test-driven development methodology, it can be ensured that the PDR application is flawless at any point in the development cycle. Improvements could be made to the JSON file, such as using the JSON linked data model. It would also provide enough development time in order to fully implement the IOTA functionalities. Finally, the actual PDR application can be deployed on the client side. And thank you very much for watching.